All right. Good afternoon, class. How's everybody doing? Not bad for a Friday? Boy, the weather was nice on Wednesday, huh?
Sure was.
So, I'd like to introduce Assignment 7. Assignment 7 is kind of, it's going to feel a lot like Assignment 6, actually. Here's a big UML diagram and create an implementation. Whereas Assignment 6, you were given all of this description in English prose. In this case, you are given a gosh darn UML diagram, which I think everybody will appreciate at this point. So, there are a couple of things that we haven't quite talked about yet. We don't yet know what an interface is, for instance. By the end of today, we will. But we have all of these classes inheriting from all the rest of these classes, inheriting, associating, and with this new interface thing that we haven't talked about yet. So, basically, your job is to implement this class diagram. The classes and the diagram represent products that are available at Tim's hardware store, not to be confused with Tim's Donut Shop. Some of them are rentable and some of them are not. Each one is a Tim's product and a commodity. You must add one rentable product that is not, and one that is not rentable. So, when you are producing your, okay. So, you'll notice that box of nails and nail gun, right? These are both ultimately products. Nail gun inherits rentable hardware, which is also a product, right? So this is a rentable product. This is a non-rentable product. We're kind of, the conceptual shift that we're going to make this during this week is that we're no longer just thinking about classes as being the same things as objects specifically. We can now think about classes as being attributes of things. So, for example, all rentable things will have a characteristic rentable, right? So, if rentable hardware implements the rentable interface, that means it provides definitions for everything in the rentable interface. So, we'll get into it, but I'll leave it there until we get into the slide, to the module, the thingy.
What's the meaning of plus sign there on the arrow?
Oh, at least one. So a Tim's order must have at least one product in it. Otherwise, that terminology is actually borrowed from regular expressions. So you have, 0 to 10, that's how you designate a specific range of numbers. Star means greater than or equal to 0, right? Plus means strictly greater than 0. You'll find this notation pops up in a number of different places, most notably in regular expressions, which I don't expect any of you to know just yet. I don't know if they teach you regular expressions here. It's a very useful thing to know, but it's also quite difficult to nail them down.
It's very arcane.
Yeah, well, they're based on a completely different model of computation, right? Regular expressions are based on a model of computation called finite state automata, which, you know, once you get used to them, they work, but, you know. Anyway. So, what follows is a discussion of constructors versus create methods. So, if you take a look at the diagram, you may notice that a lot of these constructors are absent. Oh, okay. A lot of these constructors are private. Tim's order, for example, is a private constructor. And we haven't really seen how that would be useful yet. But you'll notice that it also has a static create method which returns a reference to a Tim's order. So, the purpose of this create method, this is a particular design pattern in Java called a factory method. So, the create method, particularly, you know, in the box of nails class or in the Tim's order class, produces a dialogue with the user to collect information about the object. Name, cost, price, size of the number of nails, quantity in the box, all of that stuff. Then, the last thing that the create method does is it calls the private constructor. So the create method, it's a static method that creates an object inside of itself and then returns the reference to it instead of directly calling the constructor. Does that kind of make sense a little bit? We'll do an example at some point today. So, yes. So essentially, in this case, in the case of this, you will be writing some user interactions that will take user input from console, and you'll be doing like a standard command line interface thing for a couple of things. Basically, what this is, if you're wondering like why on earth would we do this? What this allows you to do is it allows you to break up the one big gigantic dialogue that we've had with the user up to now inside of a main method, break it up into individual chunks pertaining to the individual objects it's trying to instantiate. So it's a way of allowing us to divide it up, split it among the the classes that those interactions apply to, so that when we're looking for where to find things, it makes sense that the user interaction which creates a box of nails occurs in the box of nails class, right? So that's what the design purpose of this is. Does that make sense?
It's like adding a menu to each one of these classes.
It is, yes. It's adding an interactable menu to each one of these classes. Did you have a question?
It was in regards to the model and view thing, but so I understand that it's taking the view and sort of assigning those specific tasks to the object that it's requiring.
Mm-hmm.
But doesn't that cause
Aren't you mixing the model?
doesn't that cause a dependency issue?
Those are two different questions. I'll answer your question first. Doesn't this mix our model into our view? Yes, this is a different design pattern, right? Model view, basically the reason that they're hitting you so hard with model versus view in this class is they're trying to work you up to model view controller, MVC architecture, once you guys hit like PHP and advanced PHP. And like, MVC architecture is the current in vogue architecture for web applications for a lot of very good reasons. So what they're doing in this course is we're trying to slowly spoon feed you into the idea of model versus view, right? So that by the time you're out of this class, you will have that distinction already in your minds for when you get into PHP and you start introducing controllers, even though in reality that doesn't happen until the end of PHP. But that's okay. You have to learn PHP before you learn PHP architecture. To answer your question, does this cause a dependency issue? No, because the methods are static, right? The create method is static, so it can be called from anywhere at any time to create an instance of the object,
Okay.
including from other static methods, right? Remember that static methods can be called from instance contexts, but not the other way around,
Yeah.
right? The static method cannot call, the static method cannot call, like a draw method, right? Because it doesn't have an instance. It doesn't have the instance data to draw, if we're talking about geometry. But going the other way is no problem. In this context, the constructors are being considered static. I don't know if they actually are static. So if I had to guess, I'd say they're probably special. They behave as static things when needed and non-static things when they are not needed. Constructors are kind of special. Perhaps they're more like static things than non-static things.
Well,
But
yeah, you can't have a method call a constructor in the sense of like changing the object that it's in.
No, but you can have a method within a class call a constructor to create another object of that same type within the same class. So you can, in that way, create recursive objects. But that's, recursion is a scary word that we don't talk about yet. For example, right? One way that you could formulate a list, right, is you could say, I have my list, I have one value, and then I have another list, which is the rest of the list, right? And a list can either be that, or a list can be empty, right? So then you could have, something that looked like this off to infinity of just nested objects all the way down, right? And that's one way you could implement a list. This is how lists get implemented in languages like Lisp and Haskell. Because it's a very kind of lambda calculus way of thinking about it. But again, possible but not recommended. And wow, this is a lot of blank stares, so I'm going to just keep going. So, model versus view is directly addressed. Note that because the create methods are talking to the user, this assignment does not maintain the standard model-view separation. However, you can think of static methods as implementing the view, and the instance methods and variables implementing the model. So, we still expect you to keep all of your print statements inside of the create method, for example, right? We're expecting the user interface to be constrained to this one method. So in a sense, it's a kind of view separation. You are doing some separation, but rather than we're not separating them at the level of classes, we're separating them at the level of methods, right? Okay, further description. Use the code below to test your classes. This short program should initiate an elaborate dialogue with the customer through calls to the create method, then output the order and total rounded to 2 decimal places. So you are given the top level code, here it is. It will not be plagiarism if all of you submit it. Ha ha ha. So, here is some advice. Go top down, start with the highest interfaces and classes and work downwards. That's what the assignment document recommends. I actually normally recommend the other way of doing it. Well, it makes sense to start with the base class and then implement the derived classes, right? So when it says highest interfaces, that's what it means. It's like start with your base classes and then implement down, right? From there. But you know, this is in conflict with the normal way that computer scientists talk about what is up and down in a program, right? Like, you guys are familiar with like what higher and lower mean in the context of like programming? What does it mean to be lower level in a program?
Closer to the hardware.
Closer to the hardware, precisely. So it's talking about abstraction, right? So the high level details, right, are things like the user interface. The low level details, like classically in the assignments we've been doing so far, the high level stuff is in the view and the low level stuff is in the model, right? So normally I recommend making the model before making the view, right? Makes sense. Makes sense to start there because how you make the view depends on what is contained in the model, right? If you go to a complex inheritance hierarchy, such as this one, zoop-de-shoop, you kind of want to you want to start with the base classes and then build out the things that depend on them, right? The reason that I recommend starting with the model in previous assignments is because the view depends on the model, right? Here, our top level interfaces, commodity and rentable, right? Those classes, and they are classes, will be small, short, and simple, and not depend on anything else. So I recommend starting there. The next ones I recommend doing would be this one, because this one depends on that one. It also depends on this one, but you kind of want to eat these up in the order of, have I done all the dependencies for this class already? Does that make sense? Am I making sense? Okay. Of course, once you've done interface, Tim's product, and rentable, you kind of have your choice as to which branch you want to follow from there, right? This is not a partner project. This is a single person project, unlike assignment 6. All right? So, ignore the rest of that advice. So, what this advice is telling you to do is to just put in all of the methods that you need first, and then you can work from there, right? Go through the entire diagram, basically just do the direct translation of the UML into Java code first, and worry about filling in the contents of the methods once you've done that. That's what this advice is shortly summarized. Okay?
What does stubs mean?
What does stub? Oh, stub just means the first line. First line with no contents is a stub.
Oh,
You know, like stub Wikipedia articles? No? Okay. If you look up something sufficiently obscure in Wikipedia, you end up with a stub.
Basically, just a placeholder till you get back to it.
So Wikipedia has a article on stub articles, which is not a stub. That's funny. Let's see here. Oh, what is this? Like a very specific thing that's on Atom. I don't have a brain for it. You guys can find Wikipedia stub articles. You really only run into them if you're like doing deeper research in Wikipedia and following a bunch of links. But anyway. Are you guys aware of the game that you can play with Wikipedia? Where like,
There's a bunch of them.
if you click the first link in every article, you always eventually wind up at philosophy, I think. Have you guys tried that? Okay, try this. Wikipedia. All right, let's do the featured article, the Grand Canal. All right.
Grants Canal.
Grants Canal, all right. Grants Canal, there we go.
First one.
DeSoto Point, there's a stub article. Okay. Well, the first article that's not a stub article, Louisiana, is a state, United States, North America, continent, geographical, ancient Greek, Greek language. We might be in a loop. Okay, Indo-European, language family, languages, communication, information, abstract concept, first principles, philosophy. Boom! So every Wikipedia article has a philosophy depth, which is the number of links you have to click to get to the article on philosophy. So, there you go. Anyway. So let's do some proper work then. Let's go through some guide document stuff. I know it's a Friday, nobody wants to, but it's going to be on the test. Ooh, I should talk about the test. On the test, there is stuff from week 10 covered, but it's not very far into week 10. Basically, we've already covered everything from this week that's going to be on the test. So, good. If you want to put a particular number on it, where are we here? Man, this is a terrible mouse. Man, not smooth like butter.
Quick question about
Yeah.
the asylum. Is the create method the one that's actually printing stuff and talking to the people?
Yes.
Okay.
Yep, the create method is the one that's actually printing stuff and talking to people. It's going to have a scanner object declared. Should be local to create.
Okay.
Yeah. Because nobody else needs it, so it should be local to the only thing that needs it.
Okay.
So, if I want to draw a line for test coverage, Section 1 is covered. Section 2 is not. So Section 1 is on, Section 2 is the cutoff. We are not, the stuff on Section 2 is not on there. Good. All right, so we were talking about polymorphism last time. We didn't really do a in-class example of what is meant by the term, So I think that might be profitable use of our time. Let's load up IntelliJ. Man, it's so terrible. I hate this mouse. It's terrible. It's like, you see it skipping? Terrible. If this were a Linux terminal, I would just do the entire lesson from the command line.
There's an example code that we're supposed to get for the circle.
Yeah, there's going to be. Let's take a look while we're waiting for that to load. Yeah. Oh, did I say week 10? I meant week 9. It's tricky. Technically, this is week 10, but this course doesn't count the break week as being a week. You know? Technically, this is week 10 of the semester. So, example code. Download. All right. Much of the example code has to do with the exercises. So, let's quickly recap what we were talking about last time. We are talking about polymorphism. The purpose of polymorphism in this context is that when we declare a variable or an object reference of some class, we can insert into that slot any object of any subclass of that object. So, what it means to be a subclass is any class inheriting from you is your subclass, right? So in this case, if geometric object is the base class, then the subclasses are circle, rectangle, and target. If you are considering circle as your base class, target is a subclass of circle, right? So basically, if you take the arrows, flip them around, it becomes is a subclass of. Make sense? Come on, say something. Say, yay! Wow. Find more cheer in a graveyard. All right. So, this is a different thing, right? This is something new. What this allows us to do is work with more general categories, which can work with things as general categories, and then, insert into those general categories more specific things as needed. So let's consider. Let's take a look here. Our geometric object, once again. Did we actually load apps? Okay. IntelliJ. So let's grab the geometric object, circle, target, and rectangle. There we go. So these are more or less the same things that we had last week. Let's make a new main method, not main, a main class containing a main method. Let me just increase the font size on that for all you poor folks at the back. There we go. Is that good? Cool. So, let us create a geometric object. Oh, yeah, let's get rid of the package statements. Geometric object O1 is equal to new circle. Circle need anything for its constructor? Doesn't seem so. Okay, this will work. Geometric object O2 is equal to new rectangle. You can see that despite the fact that both of these objects are being declared as geometric objects, we are able to put both circle and rectangle into this slot. So you may be saying to yourself, big deal, right? What could this possibly be useful for? Well, dear reader, you can do this with data structures as well. So, let's imagine we had a geometric object array. Of size 10, or whatever. Each of the individual elements of this array may be anything which derives from the geometric object class. So, for example, if I wanted to initialize this as 4 int I is equal to 0, I is less than the length of, or is it object array.length? Yes, thank you. I++, one sometimes gets confused between JavaScript and Java, and I'm sure everyone in this room can sympathize. Object array at I is equal to a new something. Let's say if I mod 3 is equal to 0, object array is equal to new circle. If I mod 3 is equal to 1 or 2, we make that rectangle or target, respectively. So what we get as a result of this is an array that has a circle, rectangle, target, circle, rectangle, target, circle, rectangle, target, circle. For geometric object O in object array, X out O. And I know, like, we don't have two strings. Well, we might have 2 strings. we have two strings in these things? We do have two strings. Da-da-da-dun. Let's run this, see what we get. Ah. I mean, you should be able to find it.
I think it's misspelled.
Did I misspell something?
No, no.
Now, let's see here. Cannot find simple class geometric object. Well, it's right here. So, maybe it just doesn't like, wait, geometric data.java, let's see. Maybe it wants me to like go through its process.
Well,
Well, let's see. I think that did work. So, sometimes it does this, sometimes it doesn't. So annoying. There we go. Save that up. Let's see if this works. Number of errors is reduced. Rectangle. So to fix this, literally all I'm doing is cutting the entire contents of each of these classes, deleting the file, remaking a class using the right-click interface, which seems to be the way that IntelliJ wants to do this because it's being a princess, and you know, just remaking everything manually. Basically. Wait, is that rectangle? Yeah, rectangle. Boop, 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 boop. There we go. And there you have it. The code itself wasn't wrong, it was an IntelliJ problem. So, as you can see, what we are getting is circle, rectangle, oh, that's very small, pardon me. Exactly what I said, circle, rectangle, target, circle, circle, rectangle, oh, interesting. Oh, I get it. No, a circle here is part of the rectangle print, or the target print. Yeah. If I delete this new line, that will make more sense. And rerun. So what it's saying is that a target is a circle of radius 50, right? So there you go. So, okay. All right. All of this works somehow. Any questions about that?
I see your name.
Yeah, absolutely.
Thanks.
So. So this is useful. You guys remember JavaFX? You remember form elements? All of your form elements inherit from a common definition of a GUI element. Therefore, it is possible to do such lovely things as when you are creating a new form element, you add a reference to that form element to an array or an array list of form element references, and then you can pass that to add children instead of having to repeat all of the individual names of all of the form elements you added, which means it's much easier to dynamically add and subtract things. So, but that's, kind of neither here nor there. So, we are able to print all of these geometric objects because all of them just happen to implement toString. Right? ToString is implemented in everything, irrespective of whether the individual class contains a definition for it. Because, good, quick quiz. Why does everything have a toString method that's callable? Someone? You, sir, at the back, sir.
Because the object class is a toString method.
Say that again?
The object has a toString method.
Yes, the object class, which all things inherit from, also has a toString method. Very good. It's not a particularly useful definition, but a definition nevertheless. So, what if we look for something that's a property of a geometric object? So, looking at geometric objects, we've got a few properties. X, Y, we've got get X, get Y. Let's just use get X for now. Get X. Wow. Someone was so bored in their class upstairs that they literally just fell off their chair. So there you go. This results in no compiler errors and works. Right? Because getX is a method of the geometric object class, all objects in any subclass have a definition for it. So, we are able to call getX for our entire array. Makes sense, right? This is the way inheritance works. Does it make sense? Sort of? A little bit? Okay. Okay. So, here's a question. What if we try to pull out a property in one of the derived classes? For example, circle has a radius. What happens if we try to access O.getRadius instead of getX? Anybody care to predict what's going to happen?
It will show an error.
It will show an error. That's right, but let's see the error. Cannot resolve method getRadius in geometric object. So if we take a look at geometric object, it does not contain a definition for getRadius, despite the fact that circle certainly does. Right? So, does anybody remember the method that we used last class, or we touched on last class, to be able to get around this problem?
We converted O to type circle.
That we typecast it as circle. remember to include the correct number of parentheses to bind the cast to the object reference before calling the method. Save that. So now, we no longer have an error on compilation. Let's run it and see what happens. Exception in thread main. So the first one works because the first object is in fact a circle and does in fact have the getRadius method defined. However, class rectangle cannot be cast to class circle. Rectangle and circle are in unnamed module. So, this is the difference between a compiler syntax error and a JVM runtime error. You can trick the compiler with this, but you can't trick the JVM with this. When you actually go through the process and actually attempt to convert the object to a circle, if it's not of a compatible class, the operation fails. Okay. So, the question becomes, how do we avoid this error? There are a couple of ways we can do it. In the first case, this is an exception, right? So, even though we haven't formally done exception handling, I will show you how to use a little small amount of exception handling in this particular case to solve this particular problem. Try this operation, catch exception E, print, whoops, this is not a circle. Now, if we run it, you can see that where the object has a getRadius method defined, we get that value printed. Incidentally, why are we getting, so if this is like the three objects that we're printing, right? Why are we getting 50 twice here? Target is a circle, therefore inherits getRadius from the circle class, even though it doesn't define it for itself. Yes. This is the target, this is the rectangle, this is the circle. Right? So, when we hit rectangle, rectangle does not have a getRadius method implemented, therefore, whoops, this is not
A circle.
a circle. Precisely. So that is one method. That's called a try-catch. Once again, well, try-catches are actually like quite simple. Like they're not too bad conceptually. Basically, what happens with a try-catch, if you section off a block of code and you say, if an exception happens in this block of code, stop it immediately. Don't process a single thing more. Stop processing immediately and immediately jump to your catch statement and execute that instead. Make sense? So, that's one way of solving this problem. The other way of solving this problem is to test for the type of the thing using an if statement. So basically, this is the difference between proactive and reactive error checking. This is reactive error checking. It doesn't do anything until an error actually occurs and it reacts to it. We can also do proactive error checking. If I forgot, oh, it's called.
Good class?
Yeah, something like that. It's in here. Instance of. There we go. Ooh, that's a weird way. That's unusual for Java to do an infix function like that. Okay, you guys know what infix it means?
No.
Okay. Okay. So easiest to explain. This is easiest to explain with addition. All right. So normally we say 2 plus 2 is equal to 4. Right. This is infix. If we say add 2 and 2 creates 4, this is prefix. And if we say 2 plus equals 4, that's postfix. So most functions are prefix operations, right? Because the function name goes before the operands. In this case, x instance of circle is it's an infix function. All right? It can probably also be used as prefix. Most of them can. So, if O is instance of circle or O instance of target, I hope that works. It seems to have a yellow highlight, which means I might just be, let's see here. Always false when reached. Oh yeah, because all targets are instances of circle. So that's fine. Then we cast it as a circle. So if we run this, you can see that there's no else case, so this is a rectangle statements are missing. I can throw that in quickly so that it looks like we have one. Using something like this, you could also switch between a bunch of different options as well and do different things for different options. So there are advantages to both of these ways of going about it. Proactive error checking, proactive error checking is a little bit more forward thinking. You have to think through the problem a little bit more. You're being a bit more deliberate about setting up cases to handle things. And the advantage of that is you can do more complex behavior. The disadvantage of that is that you have to actually think it through. The advantage of the try-catch, it's reactive, so it will catch all errors when that happens. The disadvantage is it's a little less flexible when you actually do encounter an error. Does that make sense? You had a question?
Yes, the question about infix, prefix, and postfix.
Yes.
What exactly difference does it make whether it's infix or prefix, and can we make from prefix to infix?
It depends on the programming language. Most of the time, these operations are fixed, if you want to put it that way. Most of the time, the way that you say 2 plus 2 is that's not changeable in most languages. But if you consider one of my favorite programming languages, Haskell, you can actually underdefine operations to create functions. So, for example, in Haskell, if you say plus 3. Function application in Haskell is just a space. This actually becomes a function which takes the input, adds 3 to it. So plus 3, 5 will evaluate to 8, right? In Haskell, it's possible to leave both of those operands off. So in Haskell, you can write these 3 ways, which leads to some interesting situations like plus 3 minus 7, 2. You know, you can write math very unintuitively, and it'll still work. But this is because Haskell uses what's called currying, but this is kind of a tangent about another, you know, esoteric language, and we don't have to worry about it. But basically, there's a tendency to use infix function names whenever, like, the name of the function is like a preposition, if that makes sense. Like, for example, in Python, you guys may or may not have known this. Did they teach you about in with Python, like the in search? So if I have a list, right, if I say 5 in list, right, that searches the list to see if 5 is in it. This is also a infix linear search operation. That's linear search, by the way, because it can't assume this thing is sorted. But anyway.
So there is no plus or negative points of infix or prefix, so we can use interchangeably.
I don't know, you shouldn't consider them to be usable interchangeably.
If like both options are possible, like in Haskell.
Sure, yeah, if both options are possible, then absolutely you can use them interchangeably, and they mean the exact same thing. It's just, you know, like, sometimes, like, Haskell also has operators that allow you to use a prefix function as an infix function. That's what backtick does in Haskell. Whereas in, like, most C-based languages, that would mean something else. Actually, in PHP, backtick means execute this as a shell command. So you can actually integrate bash commands directly into your PHP by backticking. But anyway, any other questions about this? No? Okay. So,
You have a second, you check the codes now.
okay. Cut content, delete file, remake circle, and yeah, again, IntelliJ is just being a princess this afternoon. So, which method gets called? Let's suppose you have circle and target. They both have a draw method, right? So, both target and circle have a draw method, right? So it may be a little bit confusing, right? We have a circle, we have an object of declared type circle, actual type target, right? If we call draw on it, what do we use? The actual type or the declared type? I mean, yeah, you can just read it, right? we use the actual type, right? Remember what the purpose of the type checker is, and what part of this is governed by the type checker, and what part of this is governed by the runtime engine, right? Checking that this is legal syntax is the responsibility of the type checker. The type checker says, oh yes, of course. Circle definitely has a definition for draw, so there is a definition provided, this can run, everything is happy. When it comes to actually running it, just because you're using polymorphism in this manner does not mean that you are changing which methods get executed. If we have an object of type target, its draw method overrides that of circles, right? So, the interface that a target uses is the compound interface between circle and target. Draw has been overridden, so it is the overriding definition which is used. Does that make sense? Okay, good. So, here's another point. So, Java is a verbose language, which, is true. But as it turns out, if you know some tricks with Java, you can get it to be significantly less verbose. Let's consider a situation where we have the following class diagram. Object, we have person inheriting from object, employee and student both inherit from person, faculty and staff inherit from employee. Let's say that we were writing some methods for each of these different person types, right? Under our knowledge of Java before we got to this unit, you would need one method defined for each one of these individual classes, right? You need to overload the billing method for faculty, student, and staff, all of our sort of lowest level, most concrete classes. With polymorphism, you can write one method handling all of these classes, which, so long as this method definition is only using information that's coming from the person class, this actually saves you quite a bit of time, right? Again, this is the way that things like relocate work in the JavaFX library.
So where do we write this
Just in a main method, right? You would need to, or no, I'm sorry, not in a main method.
In the person
imagine you
class?
had some other class that was like, let's imagine you had like a class that was acting as a database of all people associated with Mohawk College, right? We don't care about efficiency, so let's just make it a super large array of person objects, right? Those person objects might be faculty, staff, or students, right? Rather than, so inside of that big long, inside of that class, you might have a billing method, right? You want to bill some particular student, right? So, or you might want to bill a faculty member, or you might want to bill a staff member for parking fines or something, right? Instead of having separate billing methods overloaded for each possible class that can obtain to, you can do it once for the superclass, and then that definition applies to all subclasses by default. And this is also nice for expansion, because if in the future you wanted to add an additional person type, right? You know, maybe you want to take staff and you want to divide it into like administrative staff and like maintenance staff or something, right? Those additional classes that you put in staff, you don't have to modify this method to expand with that capability.
But would this only work if you're billing everyone the same way, if you're billing differently?
See, not even necessarily. If you're using information from a more specific class, you can always get there using instance of, right? Yeah, same way. So like, you know, if, for example, it's parking fines and, I don't know, you know, students have to pay double the parking fine because the institution is feeling especially mean. You know, you can say if, you know, if member instance of students, parking fine equals parking fine times 2, else not, you know. You can work that in that way, but then you're back in a position of like thinking through and handling individual cases on a case-by-case basis with the possibility of having an else case that handles everything else and not having to specify. Whereas if you were doing individual methods and you had one method for each class here, it's like taking your else case and having to explode it into every single case, and basically you don't get else anymore, right? Does that make sense?
Yes.
Yeah. Good. Any other questions? That was a good question. Yeah.
So, this is why I was asking about the dynamic typecasting.
Mm-hmm.
Because even within that statement where it says person member, you still need to ask what the input is and then substantiate it or cast it to the object. So it's going to still be tedious.
Mm-hmm.
That's why I was asking. Is there a way to do that easily?
Like generate type process can be easier and
Because we're able to pull the correct class, we're able to ask if it's an instance of it. It seems strange that we can't just pull the type out of the class and then cast to it.
Oh.
Because you're asking it what the object is, and then you're just casting to it. Is there not a way to just combine those two steps to just cast to the type or cast to the class?
It's a decent question. Let me see.
Because apparently type and class are different, and I have no idea where you find anything with type. Like, how does it take the object and find type from that?
Oh, the classes are types, though.
But they're objects.
Yeah, the object has a type, which is its class.
But if you say get class and you get the class, and
Yeah.
you put it into the typecast, it goes, that's not a type, that's a class.
Ah, I see what you mean. You want to be able to convert between strings. Let's see.
Not really.
No, not necessarily.
Like, I have wolves and witches.
Yes.
They're both in a pack, and I want to compare the packs, but I had to dynamically cast either werewolves or witch to it in order to give me the get pack function. But then I just had to ask, is it a witch? No. Is it a wolf? No. Then I can attack. But if you're doing that for 50 things, that's just a giant list. Because in my brain, it's can you typecast from pulling the class? But you can't. It makes no sense.
Do I have a class? With a generic? You can put a class into? ODOT, get class? No? I think I have to stop answering this question or else madness starts setting in.
Yeah, this was me yesterday.
Stare ye not into the void, lest the void stare back into thee. This is like the deep esoteric Java. Like this is the deep. These are the deep magics, and I don't know. I'm not that good at Java.
It seems like it's simple until you actually try and do it, and it's like, no, Java doesn't support that.
Yeah. It seems like the kind of question that you wouldn't be able to get answered even on Stack Overflow.
Really?
I don't know.
Where is this like?
Anyway. Okay, good. So, moving, by the way, I found this out. Apparently in December or January, Stack Overflow, Stack Overflow now completely disallows anybody uploading answers that were generated by ChatGPT. I would love to know how they're telling the difference. But apparently, like, ChatGPT generates answers that are like they look convincing, but are wrong a lot of the time. And like Stack Overflow has a higher standard of knowledge than that which is capable of being generated by ChatGPT. So they're just not allowing ChatGPT made solutions on Stack Overflow anymore. And I think that's wise because ChatGPT lies. And yeah, it does. It lies. It will tell you a lie, and it'll look like it's not a lie. Yes?
I saw a stat the other day. Like something called like AI Devin came out or something for software engineering.
Yeah?
And like he was comparing to like what percentage of time it gets answers right from GitHub. ChatGPT was like it got the right answer like 1.4% of the time.
Yeah. Yeah, exactly. Like, no matter what you get out of ChatGPT, even if you're like best case scenario, you'll probably have to give it some reasonably heavy edits to find what you're looking for. Like, what I think is good use of it is because, and you may think, what? He thinks there's any good use of it. If you're looking up how to do like some very specific operation in a programming language, it's useful for that. It's like, for example, I do a lot of my document generation using a package called LaTeX, which is like, it's like a document generation package that's used by scientists to write papers and that sort of thing. But like, because I was a PhD for so long, I've put enough like time into learning it and skill into learning it that I'm reasonably skilled with it, and I feel like if I don't use it, I'm throwing away years of my life learning this bloody software. But anyway, it's very obscure. It's very obscure, and like, how do I do X in LaTeX? How do I set up multiple columns on a page, something like that? It can give you the answer to that very, very quickly and easily, and I recommend it for that purpose. But if you're using it to generate like whole cloth programs,
So it can't really generate like a good amount of text, but it can find the right amount of text from the internet if it's already written by someone.
yeah, and like the other nice thing about it, if you're using it just to get like a small code snippet, is you can take that snippet, put it in, see if it works or not, right? I find it's usually a pretty good hit rate for it working, like a small code snippet like that. But like if it doesn't, it's like, oh, I just lost 3 lines of code. you know, you haven't lost like the whole program. Like, I don't know. Basically, my opinion of it is it's an information theory problem, right? When, like, think of a program like this, right? You need a certain amount of information to correctly write a program to the specification, right? In order to write that, like, in order to write the program, that amount of information is necessary. It must come from somewhere. Either it's coming from, like, written description in your assignments, or you're, like, coming up with a refined version of what you want as you're programming it, something like that. But for ChatGPT to solve your problem, and your problem specifically, it needs that amount of information, right? It's my position that if you're sufficiently good at coding, it's like you encode that information as programming code, and that's actually the most efficient way for you to encode that information, right? It's like the same, like meta-programming languages have been an area of research for many, many, many years, right? Decades. Since way back in like the 80s and 70s, right? They never caught on, right? There's never been a language, a programming language which writes programs for you that's caught on, because they always run into this limit. In order to write the program in a meta program, you have to have the same amount of information as if you were working in the base language, right? So you might as well be programming in the base language, right? And not have to work with this, you know, faulty, junky meta language that doesn't do what you want half the time, right? You might as well just say what you want and do it. That's what my opinion is on the whole thing. So that's why I think, you know, essentially what is represented by ChatGPT is the next iteration of search engine, right? Rather than, it's not a person, it's not intelligent, it's not a god, right? It's a better way of aggregating search results, and that's basically what it is, right? So the problem is that it itself lies about what it is, right? It claims and it behaves as if it's a person, right? But it's not a person, right? What it is it's people reading too much science fiction. That's what it is, right? What it is people trying to re-implement Star Trek, right? Where they can just say, "Computer, could you make me a tea, please?" "Yes, good John Picard, I will make you a tea." That's what they want, right? But, you know.
They'll say, but they won't actually make the tea.
Well, I mean, in order to actually make a tea, it would have to be something other than software, right?
Yeah.
Honestly, I used to be kind of worried about it, that it's like an existential threat type thing. I think that, at the moment, I think that within, 4 or 5 years, the technology will have, reached its steady state. The marketing will have worn off. People will use it for what it's actually good at. They'll have found out what it's actually good at, use it for that, and, it'll just be just another tool, right? I don't think it's going to replace humans. My personal opinion, but some people may consider that optimistic. I do know that there are a bunch of layoffs going on right now, but Google and Amazon, places like that, are laying off a bunch of employees. This is probably why, related to why co-op positions have become a bit scarce in the last year. But they also hired, they did a bit too much hiring during the pandemic, actually. A lot of these companies, they were like, oh, everything's, they projected for some gosh darn reason. They thought that the pandemic was going to be normalcy, right? they didn't recognize the pandemic as being, you know, a special, exceptional circumstance. They projected, you know, what if this goes on forever? And it's like, well, the virus eventually went away, mostly. And, you know, now they did all this hiring on the assumption that they would need like redundancy in staff and like all this work from home and like all that kind of stuff. And now they don't need so much staff, so they're shedding staff, right? So, although, you know, a certain amount of it is, you know, they do have this new tool that makes programming more efficient and various things more efficient as well, so there is redundancy from that as well. It's like a composition of factors. The world is a crazy place. So anyway, where were we? What were we talking about? Abstract classes! There we go. So, our experience with all of these classes that we saw through the previous example should have highlighted one like thorny problematic issue, right? Which is we have all of these classes. We have circle, we have rectangle. Whether or not they implement a particular method is left to the implementations themselves, right? There's no way to constrain these methods, or constrain these classes, so that they must implement some group of methods which we expect. Until now, we now introduce the idea of the abstract class. So, an abstract, okay, well, I kind of jumped ahead of the abstract classes and I was talking about interfaces. That's okay, interfaces are the most abstract of abstract classes. So, what is an abstract class? Yes?
No.
Oh, okay. Thought you might. So, let's think about this in terms of physical analogy. All right? We have circle, we have rectangle, we have target. Each one of these are geometric figures. It makes sense to be able to draw them. The thing that they are inheriting from, geometric object, is not itself a drawable geometric object. It doesn't contain enough information. It expresses the essence of a geometric, what it means to be a geometric object, without having enough information to be an accidental or an actual existing, a substantial geometric object. It doesn't exist as like a triangle or whatever. It's like a set of concepts uniting all geometric objects without having enough information to be any particular one. So, geometric objects, in a sense, don't exist as objects, right? Geometric objects should not exist as objects. It should be an error to try to instantiate one. Enter the abstract class. If you make a class abstract, you prevent anybody declaring an instance of it. So, consider then our geometric object class. In a UML diagram, when you italicize either a method or a class name, that means that you are making it abstract. So, abstract is, drum roll please, yet another Java keyword. So, abstract, so to make a class abstract, we put the word abstract in the class header line. This opens up the ability to make some of our methods abstract. So what is the purpose of an abstract method? An abstract method is a method stub. It contains the interface but no body. It does not have an implementation. It is just the type information. What is the purpose of an abstract method? An abstract method requires all derived classes to provide an implementation for it. So an abstract method must be overridden. No option.
Is it an abstract method or abstract class?
So an abstract method. You can't override a class. That's the wrong operation on classes. So if you have an abstract method, anything inheriting that definition must override that method. Because it's the type information, but there's no executable body attached to it. You don't even use curly braces. You use a semicolon. Abstract methods can only be contained inside of abstract classes. So, just as an intellectual exercise, let's take our geometric object code and abstract it. Geometric object. Now, public, abstract, class, geometric object. You'll notice immediately when you do this on your own computer, because it's probably too small to see up here because I can't blow it up, you get two little bars on either side of your class icon. This is what denotes an abstract class. So now, if we go to main, if we try to declare geometric object 03 is equal to new geometric object, select methods to, oh, no, thank you. There we go. Geometric object is abstract and cannot be instantiated. So, abstract classes cannot produce objects. This does not mean that they can't contain instance information. They can contain instance information. Right? Although our geometric object is abstract, it still contains concrete data in the form of x and y and stroke color, fill color, and line width. I'm just going to comment that out. There we go. So, making it abstract means you can't declare an object. This is good if it doesn't make sense for you to be able to declare one. Right? For example, let's return to our physical, animal kingdom analogy from a little bit earlier when we were talking about inheritance. Right? We talked about arthropods. We talked about crustaceans. We talked about, let's say, for example, we have crustacean, right, as a class. From this is inherited crab, lobster, and shrimp. What I'm about to say is not technically true, as each one of these are families of animals that will have species within them, but let's just imagine that we're kind of working at a grade school level here, and we know what a crab is. We know what a lobster is, right? You can eat a lobster. You can only eat a crustacean incidentally by eating a lobster. Right? You can eat a crab, but you can only eat a crustacean incidentally by eating a crab, lobster, or shrimp. Right? There's no such thing, in a concrete sense, as a crustacean. Crustacean is a category, not a like a physically existing thing. Right? So, crustacean in this context then is an abstract class. Right? We would never expect just a crustacean to exist in nature, for example, right? If we found something and we said, oh, this animal appears to be a crustacean, but it is neither a crab, lobster, nor a shrimp. What you would do is you would say, okay, that is a new category of crustacean. It shares common characteristics with the other crustaceans, but, it is like a googly-doo. Googly-doos are a type of crustacean that are not any of the other ones, but still, because it's a concrete thing, it must exist at the same level of abstraction as all of the other concrete things, which means it can't be identical with the category. Does that make sense?
Yes.
I know this is straying deeply into philosophy and metaphysics, but that's why object-oriented sucks, and why object-oriented programming used to be a grad level course in universities. Until it got popular, and then everybody had to know it. So there's too much of the question of existence in it, which is a metaphysical question. What is? Who knows? What is truth? I don't know. But object-oriented programming thinks it knows. So anyway. So that's what it means to be an abstract class. Any questions? Let us now turn our attention to abstract methods. So, let's imagine, just for the sake of interest, sorry, you had a question?
So are we going to talk about association with an abstract concept?
I can address it briefly, sure. So when you have something that is associated with an abstract class, right? Okay, it's an excellent question. So, geometric object, right? Let's say we have a house which is associated with 5 geometric objects, right? We can put those in an array. We can say, geometric object array is equal to new geometric array of 5. So far, no type errors. The type error only occurs when you try to call the constructor of an abstract class. You're allowed to have references to it, but you're not allowed to have an object of the type.
Okay, so you'd have to assign to a circle eventually.
Precisely. So this, basically making geometric object abstract means that this array must only contain subtypes.
Okay.
Does that make sense?
Yeah.
So, if you had circle and triangle, you could fill this array with circles and triangles, but because you can't actually declare a geometric object, no geometric objects can go in that array. That would be a type error. Because, like, this is even true within our main method as it exists, right? If we say just declare a geometric object, this is not an error. All we're doing is declaring a reference variable to the supertype. It's only once we try to actually create it that we run into problems. Does that make sense? Yeah? Okay, good. Excellent question. So let's consider abstract methods. So if we take a look at circle, target, and rectangle, each of them have an implementation for a draw method. Each of those draw methods has the same interface, right? We provide just the graphics context, and the class does the rest. Okay. I just noticed at the time that we should be having the break pretty soon. Okay, how many people want to have the break now, and we'll come back to abstract methods when we come back? All in favor? How many people want to finish the thought? Okay, we'll finish the thought. So, so all of these classes contain this draw method, but the abstract class, geometric object, does not have in itself enough information to draw, right? But it's useful, like, we still want to constrain all geometric objects to be drawable, right? We want to make sure that anything deriving from geometric object has a definition for draw, right? There should be no such thing as a geometric object that can't be drawn, right? So, the way that you constrain this to make sure all derived classes have that definition is you include an abstract method of that type so that it forces it to be overridden everywhere. So, let me just comment out the draw method here so that we can see what this looks like. Geometric object. Here we go. We have a problem. What's our problem? Went away. It went away by clicking on it. Lovely. So, public abstract void draw graphics context GC So, a couple of things we note here. An abstract method is declared, number one, by using the abstract keyword. Number two, no method body is provided. We don't even open a code block. We provide a semicolon instead of a curly brace. Abstract methods do not contain anything. They are only the type information. You can see IntelliJ will link you to the implementations of this method. Now, we have circle, that has a method. We have target, has a method for draw. Rectangle does not. Once I actually load the file, you'll notice class rectangle must either be declared abstract or implement abstract method draw. So this appears at the level of the type checker. It is now required to have a draw method before compilation. So what is the advantage of this? Well, you know how we had difficulty with get radius because circles have radii but rectangles don't? If we want all objects of a particular superclass, if we want all subclasses of a particular superclass to have a method, we include that method as an abstract method. And that solves the problem. It means that those classes cannot be without that method, that interface. It must provide this method.
Could use that on assignment 6.
A lot of things we could have used on assignment 6.
Yes. The problem is, so this is the problem with Java, like learning Java, is that it's kind of a strongly non-linear concept, right? And unfortunately, all courses are linear learning, right? It's like we, as learners in this context, we progress through time to learn something. Time is a linear construct. Java is like the information you need to know to program Java is non-linear. You need to know like this branching cloud of ideas, and we can only give them to you one at a time, right? So absolutely, this would have been useful on assignment 6, but then again, the material from assignment 6 would have been useful on assignment 2, right?
Yeah.
So it's kind of just the nature of things. Yeah. So, yeah, like if you think about assignment 6, right? Which, judging by my submissions, there's still quite a few outstanding. We have the human class. Human has both, what is it, like ranger and healer?
Healer and hunter.
Healer and hunter, yeah. Hunters and rangers are the same thing.
Inhabitant should be an abstract class.
Right, like, well,
Human is abstract.
yeah, human is in that context abstract, and I think inhabitant is
Also,
even more abstract because it includes like all of the different creatures, right? In a sense, you know, you could certainly have integrated abstraction of classes inside of that structure, but you didn't know it yet, so we didn't expect it.
It's just not properly.
Yeah. So yeah, that's the long and the short of it. All of this, the point of all of this is to be able to have compiler errors instead of having runtime errors, right? Generally, the way that you make a program do what you want is you think it through before you hit compile, right? All of these mechanisms are ways for you to force yourself and others to think the problem through thoroughly and cleanly before you hit compile. That's what the purpose of all of this is. Because, as I've said a couple of times already, which is true because of Turing completeness, any program we write in Java could be written with loops and if statements and assignment statements in one big main method, right? But, you know, it's not good design. We're trying to teach you good design too, not just how to clunkily plunk something out like a bedroom programmer. There should be a difference between you guys and bedroom programmers, right? There should be some advantage to paying the money to come to school and learn the concepts. And the advantage is you can work with other people on programs, whereas that's very difficult for bedroom programmers. There's a reason bedroom programmers tend to be single-person projects, right? Companies like it because it makes the code more maintainable and costs less to do. Like the problem with the bedroom programmer is that like particularly, depending on how much no life they have like almost infinite time to throw at a project, even though they're just one person, you know, depending on how sad and lonely they are. So, you know, not everybody can afford to be so loose with their temporal resources, shall we say. And also being able to think through a programming problem correctly and implement it using these types of restrictions means you yourself spend less time in the most frustrating part of coding, which is
View, the main.
debugging. Yes. Like, it's good to be a good debugger, but it's even better to not have to debug at all, right? So, anyway, why don't we have a break? Let's resume class at 3:03, and yeah. Cool. Oh my goodness.
I know about the hospital.
Okay, so
It's with the transit.
it was like last week that this finally came out in the news, but this problem is almost a month now
Yeah.
that it's been ongoing. The city of Hamilton done been hacked, so
Huh?
a huge ransomware attack has been affected against the entire city of Hamilton's database, basically. Like right now, community centers and like pools and things cannot process payment, so everything is free.
I should listen to Joe.
They've lost their entire database on parking tickets, and they've lost their entire database on property taxes. They've lost children's immunization records. And when I say lost, you guys know what a ransomware attack is, right? That's basically
Nice.
someone goes through and encrypts your hard drive for you and says, I will give you the encryption key for $1 million, which is a reference that people might not get anymore. So that's Austin Powers, which was a popular movie in the 90s. I think it's Mike Myers, isn't it? Yeah. Not the fictional serial killer, but the actor. So anyway, yeah, it's still going on. They haven't paid up. So yeah, the entire city, like the phones don't work at like City Hall because they're all on voice over internet protocol. The bus dispatcher is down, so they don't know where the buses are. They can only guess
In my
where the buses
way.
are.
In my way,
Yes,
always.
yeah. Like,
Straight again.
oh my goodness, it's like so much has been hit that I keep hearing about new things that are down right now because of the cyber attack.
Is that why all the flags are at half-mast?
No, there was
No.
a shooting downtown.
What? Sorry?
There was a shooting
There was a
downtown.
shooting downtown, yeah.
In Hamilton?
Yep.
Yeah,
Just a few days ago.
All the flags are everywhere
Nice.
at half-mast, and I don't
Somebody
understand why.
died.
Yikes. Was it like what was the purpose?
Drive-by shooting?
Yeah,
Mm.
just someone was a little over enthusiastic with a gun or something. Gross. Murder is wrong, and everybody should remember that. But yeah, so the cyber attack is kind of an interesting case study because like they've been warning us about this type of thing, and it's like finally people trust the computers enough that a cyber attack like this can do some real serious damage. You know, maybe they're practicing for Toronto.
And Joe Biden tries to warn everyone and to get on his case.
It wasn't because of C, okay? What? Yeah, I was asking John Holloway, who's a guy reasonably senior in the networking side, who's probably going to retire in the next couple of years. I asked him, so is this like literally as simple as someone clicked like a bad link in an email? And he said, yeah, maybe.
Probably, yeah.
Possibly, yeah. Well, see, See, this is interesting, right? Because it doesn't seem like it's just an SQL injection attack, right? Because if it was just an SQL injection attack, they would have lost the databases, but you wouldn't have lost something like voice over internet protocol or the dispatcher, right? It's more than just the database going on, right? So what I think is that they managed to get the root privileges to the whole damn thing.
Someone's an admin account and was just
Yeah.
messing with things.
Precisely. It's not like they must have lost admin privileges on whatever the main server they're using. And, you
It's
know,
just as easy as clicking on the wrong email.
Well, it's
Yeah.
probably whale fishing.
That's why all you network people are gonna earn $200,000 a year.
well, not to advertise a product or anything, but this college does offer a postgraduate certificate program in cybersecurity, and you don't require any particular, you're not required to have taken any particular program to get into it, as I understand it. So I think anybody, if you're interested in doing an extra, doing a victory lap and picking up a lot of cybersecurity stuff, that's a thing.
Young people.
Yeah. Well, I mean, it's the new frontier in warfare, isn't it? So, you know. But yeah, that's been going on for like a month now.
I haven't noticed.
Yeah. I mean, isn't that kind of nice though? It's like, oh, the municipal government is completely shut down for a month. I didn't really notice.
And the scofflaw who hasn't paid his property taxes in 3 years is like, yes!
Victory!
I can continue.
Oh, you know what's going to be bad is when the city expects us to produce all our receipts. Oh boy.
Dude, you've got 1,100 emails in your inbox. You might want to-
Okay. So, all right. We do have to continue learning, unfortunately. All right. So, abstract classes. Okay. Abstract classes seem like they might be useful for some things. What happens if we make our class the most abstract class possible? What if we push it to the limit, push it to the extreme? You end up with a thing called an interface. So an interface, first of all, you declare it with the word interface instead of the word class. So interfaces are not classes. They are like classes, but basically an interface is a class where everything in it is abstract. So it is only permitted to have abstract methods. So, all methods have to be abstract, and all variables must be static, public, and final. That is to say, constants. They must be given a value when declared and are not permitted to change at any point during execution. So, subclasses do not extend interfaces, they implement them. So when we, very sneakily take a look at assignment 7, we notice we have interface commodity. In UML diagrams, when you have a dotted inheritance or a dashed inheritance arrow, this is not extend, this is implement. All right? But, fundamentally, there's a reason it's still the same arrowhead. Implementation and extension are, they're very, very similar concepts. Mechanically, they work the same way, right? The same rules apply in both situations.
Yeah, it's not working.
So,
See, it's stuck there and I can't even close this window.
your computer is giving up the ghost?
Totally. The cross button disappeared from IntelliJ.
Write down the service tag number for that machine and email it to me. You guys, you have the numbers? Okay, I'll take them from you after class. I'll submit an IT ticket. If anybody's computer breaks during the lesson, write down the service ticket number and I'll forward that to IT and make it their problem. See, this is the problem though, is like most professors don't do that step, so the computer is just getting increasingly busted over time. So like we don't have a proactive IT department, we have a reactive IT department. They do not go out and test the computers at any point ever, so far as I'm aware, unless they've been asked to change them somehow. They are completely dependent on us reporting problems to them. So if nobody actually reports any problems, the computers just get increasingly busted over time. And college saves money. So,
We still need that international student cap now.
if you want to talk about that, we can do so off camera. Because I'm pretty sure, I was at a meeting Wednesday last week where they all the staff, it was a big staff meeting, 400 people were in the Zoom call, and basically they said, don't talk to the press. The press, so,
Fair enough.
So, not that it's not exactly juicy, the secrets, but, whatever. So, anyway. Interfaces appear in italics on UML diagrams, but will also have the word interface included here. This is to distinguish them from abstract classes, because without that, you'd have to look at the methods contained and see if they're all abstract and then infer that it's an interface, which better to have it explicit and written in black and white.
I agree.
Words by gum. So, let's consider the following UML diagram. We have interface edible and abstract class animal. Pardon me. We have class chicken, which implements edible, but is an extension of animal. So a class can only extend one other class, but it can implement as many interfaces as it likes. So this is how Java implements multiple inheritance, which is a thing that other languages just do by default. They'll just smush class definitions together, like Python does this, for instance. You can just multiply inherit from multiple classes and it just works. In Java, because Java is Java, its inheritance, its strict inheritance extension hierarchy must be a tree. So it always must have one base node from which all the rest of the nodes are derived. So each class is only allowed to extend up to one other class, but any number of interfaces can be implemented in a particular class. So edible is an interface which provides a single method, which is how to eat, string. So how to eat a chicken. How do you eat a chicken?
Raw.
Well, you have to catch it first. Yes. How do you eat a fruit?
Grow them
Yeah,
first,
that's-
get them
Yeah.
first.
I don't know. I'm trying to think of a punchline, but wait.
By opening your mouth.
By opening your mouth, yeah.
Take it to dinner first.
Take it to dinner first. Oh. That's pretty good.
That might be illegal.
So it goes, yes. So there's a difference between our interface and our abstract method, right? Our abstract class, pardon me. Our abstract class is animal. Animal provides one abstract method, sound. So tigers implement sound, tigers make a sound. And chickens also make a sound. Those are two reasonably different sounds. So the conceptual difference between an animal and edible is an animal, although it's an abstract object, it's still a description of a thing, right? Like crustacean describes an animal, right? It's like a crustacean, like in its it's the essential form of something that exists, right? Animal is the essential form of tigers or chickens or, bees and hummingbirds and sea cucumbers and anything in the animal kingdom, right? The essence of what it means to be all of those things is contained in the definition of animal, right? That's different from the interface. Interface is basically a quality, right? It's not a thing, it's a quality, right? It's a qualia. If you wanted to put it into philosophical, metaphysical terms, it is qualia rather than substance. So, it means something to be edible, but edible by itself doesn't exist, right? There is nothing that is edible without being edible through something, right? There's like...
Does a tree make noise when it falls in forest? That kind of thing?
Yes, it does, right?
So compresses the user.
Yes.
Why can't that just be a Boolean though?
You killed me. You killed the prof. Yes, it could just be a because it's an example meant to illustrate the purpose of an interface. Obviously, interfaces can be more complicated than this. One of the interfaces that we are going to talk about after the test territory, if we get to it, because array lists, When we talk about array lists, right? You remember me talking about arrays, and you remember me talking about lists and saying that arrays and lists are very different things and that they're not the same thing at all. And then Java has this wonderful, strange thing that's called an array list, and you may be wondering to yourself, how does one fit two contradictory data structures into a single class? This is how. It is an array implementing the interface of a list. Right? So, although the data structure underlying it is an array, it provides all of the methods provided by the list definition. Right? So, in Java, you have you can have the list interface implemented by either an array or a list. You choose a different class for that, but both of those implement the same interface in list, right? So what that means in effect is it doesn't matter which of those two data structures you use. In both cases, you can expect the same methods to exist for them, right? You don't have to do one of these frustrating things like, for example, in PHP, which I actually like PHP, but it has its foibles. In PHP, if you want to take the length of a data structure, the function name for that is count. But if you want to take the length of a string, you have to use string length, which is actually a function from the C standard library. Both are linear data structures. It doesn't make sense why you should have two different function names for the same operation over such similarly structured data. Doesn't make sense why you would need that, right? All it does is confuse the mind and the programmer, right? Even though, like, PHP is a strongly C-derived language which has been brought kicking and screaming into the age of object-oriented programming, and only, like, to say it's been reluctantly adapted is to understate it. So anyway, it would make sense if everything to which the idea of length applied had a dot length property, or minimally a method, right? It would, like, because that way you don't have to remember which functions apply to which classes or which data structure types. You can rely on length normally existing, right? But of course, this is programming in an age. This is almost becoming an archaic way of thinking, making things easier for human beings to understand. One of the things I kind of predict is going to happen with ChatGPT is because it will allow people to, like, just like their base of knowledge of functions is just going to be, like, they won't have to remember all of these individual cases. They will be given them by, like what's it called, GitHub Copilot or other similar things. You won't have to remember this anymore, so it's not going to be a problem that you had to in the past, right? So, like, we could be looking at a future with, like, intensely complicated programming languages that pass beyond the ability of human beings to program by themselves. That's, like, one of the possible futures if this technology takes off in that particular direction. So, personally, I think that would be a loss. I think, but, you know, whatever. This lecture is already too philosophical. So, if we consider the declaration line for chicken, public class chicken extends animal and implements edible. So, you can use a comma-separated list of all of the interfaces which a particular thing implements. Interfaces are a contract. If you implement an interface, you are contractually obligated to implement the abstract methods it contains, which is a legalistic way of saying that the compiler will enforce this. So if you implement an interface, the type checker and the compiler will throw up errors if you haven't implemented all of the abstract methods contained in the interface. I'm sure all of you will run into this plenty when you talk about assignment 7, or when you attempt your implementation of assignment 7. So,
Does interface have more than abstract methods, or is it only that?
only abstract methods. Abstract methods and, what is it? Constant public static variables, I think they said. Yeah. So you can include variables, but they must be static, public, and final. So they must be static because it's an interface. There's no way it could ever have an object. So you can't have any instance variables inside of an interface. It must be public because in the absence of any methods that exist, in like a physical sense, there's no way to get private information in or out, right? So it must be public. And it must be final because they wanted it to be. I don't know why. Good. So, So let's take a look at some of our example code. We have animal, apple, chicken, edible, fruit, orange, test edible, and tiger. All them things. Refactor. There we go. So we can see we have abstract class animal, which provides an abstract method sound. Apple extends fruit. How to eat returns make apple cider. Chicken extends edible. How to eat fry it. Sound. Chicken says cock-a-doodle-doo. Although I did guess that's technically rooster. I'm going to modify this. Buck, buck, but gawk.
Can you zoom that a bit, please?
Certainly.
Thank you.
There we go. There we go. So, okay. So I would like you to direct your attention now to the exercises, which I now realize are misordered. The exercises document, which contains a UML diagram for all of these classes. Here. Yeah, we don't have that, right? So, this is the interface that we're now looking at, right? Or this is the UML diagram. We have fruits with oranges and apples as subclasses. All fruits are edible, right? But they do not make sound, right? Because they're not animals. You can see animal is here an interface, whereas right now it's an abstract class. So our first task with all of this is to change our source code that we received in the examples so that this is now implemented. So we need a couple of things. We need to change animal from an abstract class into an interface. Second, we need to create a new interface, catchable, have chicken extend it or implement it, and then we need a new class, bat,
And have
which
implement.
implements both catchable and animal. Does that make sense? So, let's first work on animal. There we go. So, how do we make this into, I like, this one is so easy. I would not even, like I'm not going to insult you by making this an in-class activity. Somebody, how do we make this into an interface? Someone other than you. Yeah.
Get rid of the abstract class and interface.
Correct. You'll notice you will notice that nothing in the animal interface is still syntactically correct, as all it contained in the first place was this one abstract method. However, by making it into an interface, we have caused some problems. So let's, I will leave it as an exercise to the reader, take the next couple of minutes and solve these two related problems that have been produced. All right?
you open that UML side by side?
The which, sorry?
The UML diagram for this.
Oh, yeah, I can do that. That is a reasonable request. Okay, so, first problem. So, to find your related problems quickly and easily, you click on related problems, and then it gives you a drop-down list of where all your problems are. So, let's take a look at chicken. Our problem is that chicken is extending animal, but no interface expected here. Animal is now an interface. So, rather than extending animal, it is implementing animal. Chicken implements edible animal. Oh, you want it alphabetical? Okay. If you wish. There we go. Same problem here. Instead of extending animal, we are implementing animal. There we go. Rectangle has an error because it's not. I'm just going to do this so that everything compiles. There we go. So, animal is now successfully changed to an interface. Now, we need catchable. So, catchable is an interface. Right-click, new, Java class. You see that we get a drop-down menu of class, interface, record, enum, or annotation. Interface is the one you want. Oh, I have to pick a name. Catchable.
Oh, totally.
Oh. Nasty. Now I'm going to have to refactor. It's actually easier to just delete it. There we go. So, what are we adding to this interface?
Abstract method,
An abstract method. What is it?
how to catch,
How to catch. Returning?
string.
Good. So, public abstract string Oh. Right, I guess that makes sense. String how to catch. Right. So you don't actually need the abstract keyword if you're inside of an interface. All of your methods have to be abstract by default, so you just leave the keyword out. It's one of the few instances where Java is being less verbose rather than more. So, what implements catchable?
Catchable. Chicken, bat.
What implements catchable? It's chicken and bat. So,
We don't have bat yet.
we don't have bat, but we do have chicken.
Yeah.
So, add catchable. You'll notice that this introduces a problem. Class chicken must either be declared abstract or implement abstract method how to catch in catchable. So, given that our solution to this problem will not be abstract chicken, we must add our method. please take a minute or two and add your own version of the method. More points for humor. You will be expected to share your punchlines with the class. Yeah.
Can you open the catchable till then?
Yeah, I can. Yeah. Oh, sorry, catchable?
Yeah.
Yeah. Very simple. Question?
Why don't we have abstract in that manner?
They all have to be abstract anyways. Like they're constrained to all be abstract, so there's no point in having an abstract keyword here because the purpose of the abstract keyword is to distinguish which methods are abstract and which are not, right? Because they all are, there's no point in saying it.
So we can remove it from animal way.
Only from the interface.
Yes, in fact, you will have to, I think.
But it allows.
Oh, did it? Did it allow it in animal?
Yeah.
Weird. Wait,
It's allowing
animal, see here.
Yeah, even so you can put it in catchable.
catchable as well.
Oh, but why was it telling me I wasn't allowed to? What?
It doesn't let you like.
I don't think that's the problem though.
Well, obviously not. Huh.
Because I don't have abstract or public and it doesn't care.
Yeah. Okay. So in typical Java fashion, you're allowed to be as verbose as you like.
Where's the problem, Mr. Chairman?
It's missing the method.
Yeah, there's no how to catch method.
Okay, you're not in it.
Right. So, public string how to catch. Whoa. Return null. It's probably wrong. All right. How do you catch a chicken? I'm expecting a humorous response.
Where you cross the road?
Yeah. Wait for it to cross the road first. There you go. Did anybody else have any honorable mentions?
Carefully.
Carefully, yeah, that's always a good one. Bribe it with a buck. All right. There we go. And now, if we want to create a new class, and I realize time is running short, so we'll just do this one. Let's make a class for bats. What do bats implement again?
Animal.
Catchable and animal. There we go. So now it's telling us what we need to implement. We need sound from animal, yeah. Public string sound. Return key.
What's it, justice?
Oh,
Batman.
no, see, if it were Batman, it would also have to, like, Batman would be a class that was extending man, implementing the interface of bat. So we have done this work, but the computer is still not satisfied. We must also implement how to catch. Public string how to catch. How do you catch a bat? Humorous responses preferred. Like a line from a Batman movie would do here. Yeah.
With darkness?
With darkness.
Kidnap Robin.
Kidnap Robin, that's good.
That never works.
Yeah,
So that's Jason Todd.
there you go. So, abstract classes, interfaces, and implementations. This is required knowledge when we talk about exceptions properly. But for now, just keep this stuff in your brain, but keep the stuff that's going to be on the test more in your brain. Question?
So interface should have like input and output statements, right, for the assignment 7? So-
Ooh, let's take a look at assignment 7 since we're on the topic. So interfaces should have what?
Input and output statements, right?
What's the interface now?
Like
What do you mean by input and output statement?
I was supposed to put this in
Sorry, say again?
chicken, right?
A dialogue with the user?
Oh, the dialogue with the user. No, those go in, so the dialogues with the user must be contained in classes which can have methods that have bodies in them, right? You'll notice commodity implement has 2 abstract methods. Rentable has 3 abstract methods, but you'll notice like all the rest of them. Tim's product is an abstract class, but it doesn't actually have any abstract methods, right? The create method is a static class, or a static method of a class in the normal sense. So no, the interfaces do not have, they do not require the existence of create methods. Though perhaps they should, actually. Like if you think about it, right? You've got, if you think about your product hierarchy, you've got a create method here and a create method there, which means that ultimately both of these things are implementing create, right? So you could include create as an abstract method in commodity, right? And that would constrain these so that they must have a create method. And that would probably even be good design because commodities and what commodities are available is something that's like strongly in the category of likely to change, right? So like if this thing were expanded, it would likely be expanded in this direction or widthwise here, which means constraining things so that they must be able to create themselves, since that's what everything else does. It's probably a good idea, you know? But, you know, there's a point at which, like, I begin to strongly think that, like, a lot of the UML diagrams in this course could be done much better than they are, and we've reached that point. Yes?
So if you have an interface that's saying you have to have a create method, and then I create something that's just above it that provides a create method, does everything inherit that so that satisfies that?
Yes.
Okay.
Like, if Tim's product itself had a create method, that would satisfy the requirement for a create method provided, that's given by the interface. But anything like box of nails or a nail gun would override that definition. Like, you're allowed to implement the interface more than once by overriding it. Right? So, if I had create here,
Yeah.
right, and I had create there, I can still have create here. This
just
one
implement.
overrides that,
Yeah, okay.
right? And like, I only need one of those to satisfy the requirement of the interface.
Would it be bad practice to implement the same interface multiple times throughout the chain of inheritance?
Not necessarily, because take create for an example, right? What it means to create a rentable, something that's rentable, is different from creating something that's non-rentable. There are some fields you can populate here without knowing what specific product you're talking about. Right? So a create method here overriding this one here would be useful. It's almost, you could have create at every level, actually. And you could even like use super to minimize code redundancy as well, like all rentable things establish the rentable properties rent, return, and is rented by calling the super, the super version of create.
Okay.
Right? So yeah, you could do it, and I think it would even be good design. Question?
For the test,
Yes.
where's the cutoff on top of people learning what's not going to be on the test?
Module 1 of this week.
Okay.
What's the naming convention on these bloody things again? Guide, yes. So guide document, section 1 only
So polymorphism
So
is
polymorph-
included.
And then everything after that, not there.
is for the exam, yes.
Okay.
Only that which I am currently highlighting is testable on the test.
And we have a test review on Wednesday, right?
Correct.
So-
There you go. All of the highlighted stuff is test material, nothing else.
Have a good week.
Have a good weekend, everybody.
Bye.
Oh, good. Congratulations. All right. Let me just grab my camera.
Can you just publish the test paper?